So you guys actually already know how to break things down in components. So if we again draw a top view of the class, so we've got our y, our x, over here is the podium, I'm standing over there. Over this, here we had, our null is at two ends, one end, like that, double L, E. Wow, I've got a penchant for picking good names tonight. And then Ilana, it's just E-L-A-N-A. Okay, so I now walked in a straight line to a point somewhere over there. Then I asked Ilana to move to exactly the same point as Anel, but she could only walk parallel to this wall, so parallel to the x-axis, or parallel to this wall, which is the y-axis. So Anel could choose one of two ways to go about it. She could either walk first along x, then along the y, or as she did, she could first walk along y, and then along x. And what this basically tells us is if I've got any old vector, so which I will again call R, I can always write this as the sum of, in 2 dimensions, 2 components. And these 2 components are just vectors pointing in the direction of our previously agreed upon system of axes. If you recall, on Wednesday we said, well, we've got freedom to choose how we're going to specify things like position. We can use a system of rectangular coordinates where we specify an x and a y axis, or we can use a system of polar coordinates. Here we worked with rectangular coordinates exclusively. And we show pretty obviously that any vector I can decompose into something along x and something along y. And we're going to use mathematical notation for this. So the way to write this is to say the vector r is equals to a certain distance along the x-axis. Now, how will I indicate along the x-axis mathematically? I'm going to use a little I with a cap on it. So this just means so much, or a certain magnitude. That means along the x-axis. And then to that I just add a certain amount, so much, along the y-axis. So how will I indicate along the y-axis? I'm just going to use a little j with a little cap on it. So all that means is along the y-axis. So this is just the mathematical way to say what I did. I told Ilana in simple English is first walk a certain distance along the x-axis, then you walk a certain distance along the y-axis. So if you see something like this, it means you must do something in one direction and then you do something in another. Yes, I've got a few questions. I think your hand went up first.
And may I ask, why isn't it Pythagorean? Because isn't it a right angle triangle?
I'm going to use that relationship now to, we can actually use Pythagoras' theorem to convert, to say we know how far Anel walked, we can figure out from our sines and cosines exactly what that distance is and what that distance is. Or alternatively, if we know how Ilana walked, so how much along x and how much along y, we can figure out with Pythagoras' theorem what the direct distance was between these 2 points.
Yes, that's what I'm asking. I'm asking then, why isn't r the x squared plus y squared? Why is it just x plus y?
Okay, so if we were to use x squared plus y squared, the only thing we will be getting is the magnitude. Yeah. Remember, for vectors, we always in magnitude and direction. And I'm also introducing this notation now because you'll see a lot of times if I ask you to add 4 kilometers east to 10 kilometers north, it's very difficult to draw 4 kilometers on a piece of paper. So we need a way that you can mathematically calculate these sums, and this notation makes that particularly easy. So that's what we're going to do in a second. Yes, your question. Okay, so please take note, if you see something like this, just think twice before you do your next calculation, because it really means do something in one direction, then do something in another. So that, what I've written there, is not equals to a simple number. It specifies 2 magnitudes in 2 different directions. And as of now, it's still a bit hazy how we're going to work with this, but that's what I'm going to show you now, is if we stick to this notation, things actually become rather easy. So just for now, if you can remember that what I've written down there is you go so far along the x-axis, and then you go so far along the y-axis, we're fine. Okay, is everybody okay with that notation? Okay, great.